Hey there everyone and welcome back to the Geeks for Geeks channel. And this is another video in the series of competitive programming. And today we're going to talk about Walmart's unique path problem. Obviously, the name suggests that this is asked in Walmart. Okay, so we have to find the number of unique paths a customer can take under certain rules. So here we go. So the question is as follows. Your friend Akshit is a software developer at Walmart, and due to COVID-19 pandemic, there has been a decline in the work he has to do. But his manager can't bear if anyone is sitting idle. So out of curiosity, he imposed a rule in his store that all the customer can only enter the building from the top left entrance and can only leave from the bottom right exit. And they can only move either their right or down in the store. Now, the manager wants Akshit to calculate all the possible unique paths a customer can take from entering to leaving the store. Now, since Akshit is weak in competitive programming and you are a very good competitive programmer, so he calls you to help him out of this situation. Now, let's talk about the question in a brief. So, we are given a M cross N matrix with your initial position at the top left cell. And we have to find the number of possible unique paths to reach the bottom right cell of the matrix from the initial position. Note that the possible moves can either be down or right at any position in any time. That is, if we are at matrix position I, j, we can only move to matrix I plus 1j or matrix I j plus 1. Now, this question is very similar to longest common subsequence and it uses dynamic programming as well. How we know that it uses dynamic programming for solving this problem? So as we can see at every step, we have two choices. We can either go to the right or to the down. So this is how we find out that this problem is of dynamic programming actually. So now let's talk about the input and the output constraint. So the first line contains an integer t depicting total number of test cases. Then following t lines contains and two integer a and b depicting the size of the grid, that is m cross n. Okay, so we have to print the number of unique paths to reach bottom right cell from the top left cell, and these are the constraints for the problem. Now let's try to understand the problem by taking an example of 1 cross 1 matrix. Okay, so if we are given only one cell, this is the entrance and this is the exit itself. So there are how many unique paths possible? There is only one path possible. Okay, so now let's take 2 cross 1 matrix. So there are 2 rows and 1 column in this matrix. So the entrance would be this cell and the exit would be this cell. So now again, how many unique paths are there? There is only one path that we can take only a down and then we can go for the exit. Now let's take another example of 1 cross 2 matrix. So we have to enter from this cell and exit from this cell. Now again, there are only one unique path for all of these cells to pass through. We can only take a right from the first cell to the last cell and then we can go out. Now let's take another example of 3 cross 1. So now why we are taking all of this example? So I'm trying to explain you how we are going to approach this problem. Okay, so let's say we have got a 3 cross 1 matrix. So the entrance would be from this cell and the exit would be from the last cell. Okay, so again, how many unique paths are possible for this matrix? Only one path. We can only go one down, then another down, and then we can exit the building. Okay, so now let's talk about our input. So the first is 2 cross 2 matrix. So now let's talk about 2 cross 2 matrix. Okay, so we have to enter the building from this cell and exit from the bottom right cell, that is this 2 cell. Okay, so how many possible paths are there for entering to this cell and when we have to exit from this cell? Let's count it out. I will just draw it with another color. Okay, yellow. Okay, so one path could be take a right and then down, and then we can exit. Okay, and the another path could be take a down and then take a right. Are there any other paths possible apart from these two paths? No, there are no two paths. So we can conclude one thing, that the number of paths in this 2, cell depends on the number of paths possible for the cell above it, just above it, and the cell just to the left of it. So now let's take another example of a 2 cross 3 matrix. Okay, so in this case we have to enter the building from this cell, that is the top left corner, and exit from the bottom right corner, that is this cell. So now we have now this numbers here are the number of unique possible paths, as we can see from other examples. So we have gathered the information about the 2 cross 2 matrix, that what are the number of unique possible path for all of this cells. Okay, so now, and also we have gathered the information about 1 cross 3 matrix, that what are the number of possible unique paths for from going through this matrix. Okay, now we have to find out the what are the number of unique possible path to go from this cell, first cell, to the bottom left right cell. Okay, I will draw with another pen again. Okay, let's count with me. First we can take a right, then we can again take a right, and then go to down. Okay, this would be the one path. What could be the another path? First we can take a down, then we can go right and again right. This is the second path. Okay, what else path we can take? We can go right one time, then down, and then right. So there could be only 3 unique possible paths. So again, as you can see, the number of unique possible paths for entering a building from top left corner and exiting from bottom right depends on what? Two cells, that is the cell just right above it and the cell to the left of it. As we can see, there are only one unique path to go from the top left corner to the top right corner, that is this cell. Only one unique path, and there are two unique paths to go from top left corner cell to this cell. Okay, so the number of path from going from top left corner to the top bottom right cell would be 2 plus 1 3. Okay, now you are getting my point. Let's talk about this matrix, that is 3 cross 4. Okay, so we have this matrix over here, so I will just use red pen again. So we will be entering the building from this cell and exiting from the bottom right cell, that is this cell. All right. Okay, so now let's count with me that how many possible paths we have. So we have known that for the first row and for the first column we have only one unique possible path, that is either take only right or either take only down each and every time. So now, as we can see from the previous examples, that the number of unique paths depends on the either to the cell just above the cell or just to the left of cell. Okay, so in this case, what would be the number of possible path to go from this cell to this cell? So 1 plus 1, that is 2. I will just write it down with another pen. Okay, so 1 plus 1, that is 2. Okay, so we will traverse the matrix from row by row. Okay, so now what could be the number of possible path from to enter the building from this cell and exiting from this cell? Okay, we have done this before. Okay, 2 plus 1, what is this? 3. Now again, what could be the number of possible path for this cell? That is 3 plus 1, 4. Again, for this cell, that would be 2 plus 1, 3. There are 3 number of unique paths from entering from this cell and exiting from this cell. Again, 3 plus 3, 6 unique path for this cell, and 6 plus 4, 10. So there are in total 10 unique possible paths from entering to the building from the top left corner and exiting from the bottom right corner. Okay, as we can see, we have got the correct output. Now remember that number of paths to reach any cell will depend on two previous states, that is upper nearest cell from where we can reach current cell and left nearest cell as the sum of the number of paths to reach these cells. Okay, so what is the base condition for this question in the dynamic programming? So the base condition would be this: the first row and the first column, the number of unique path for this, the value of this cells in the first row and the first column would be 1. As we can see here, matrices I comma 0 will always be equal to 1 for any value of I, and matrix 0 comma j will always be equal to 1 for any value of j. Now let's talk about the steps we need to write the DP solution for this question. For any DP solution, we have to follow this 4 simple steps. So what is the first step? We have to create a matrix mat of m cross n size. Okay, then the second step is to find the base condition. We have found the base condition over here, that is mat 0 comma j and mat I comma 0 will always be equals to 1. So this is the base condition for this question, and then we have to find the logic to fill this table. So what is the logic we are using to filling this table? That is sum of matrices I comma j is equals to sum of matrices I minus 1 j plus the value in the matrix I comma j minus 1. So the what is the logic we are using? We are using the logic that the value in this cell, this particular I comma j cell, is equals to the sum of the values in the just cell above it and the just cell to the left of it. Okay, for every cell. Okay, now at the fourth and last step would be we have to return the value at the cell matrix m minus 1 n minus 1, that is this last value which we have calculated. So this would be the steps we will be following for our DP solution. Now let's talk about our solution. Okay, so I'm here at Geeks for Geeks side and I will just maximize this coding part and zoom it a little bit. Okay, so now we will start and write the code for this solution. Okay, so first of all, I will just delete all of this stuff and include some header file necessary for this. So first of all, I'm going to take care of the input format. So just give me a minute. Okay, so now we are going to move forward to the first step of our solution, that is creating a matrix of size m cross n. So the m here is A and n here is B. I can take this capital M also and capital N also. Okay. Now we will move forward to our base condition. Okay, so I'm just going to write a simple for loop to satisfy our base condition. Okay, so now we will move forward to a logic to fill the table, that is this particular line, that is matrix I comma j is equals to matrix I minus 1 j plus matrix I j minus 1. All right, so I will use two for loop, nested for loop for this purpose. And at last we will just return the value m matrix m minus 1 n minus 1. And with this our code is complete. So I can just go out from this, zoom out a little bit, and we'll just try to run the code. Okay, as we can see, I just lost CIN. Then again we will try to compile it and test it. There are some errors which probably you will also go to. Some typos are there always. Okay, so as we can see, our output is correct and our code is correct. Okay, so this was the C++ code for you guys, and as you can see, this is the same C++ code. I've just used m and n instead of a and b in the code, which I've just done before you. And this is the Python 3 code. This is the same code and with the same logic which we are using. As you can see, we are just using the base condition over here, and we are just satisfying the logic to fill the matrix and this condition and returning to this. And this is the Java code with the same steps. Okay, so and this is a more space optimized approach in C++, where we only create a matrix of size n. And this is the solution. If you want to go for this, you can also go for this, but this code will also pass all of your constraint and all of your test cases with in the given time limit, so you will be good to go for it. And okay, so I know guys, it's a little bit hard to explain and understand dynamic programming problem and their explanation onto a presentation instead of a pen and paper and copy or a blackboard or something. So I hope you understand all of this questions and all of this explanation. This was the first question of dynamic programming in our series of competitive programming. If you like this video, give us a like. If you have any problem or any query or any suggestion regarding this video or how better I can explain dynamic programming problems and their explanation, please comment them down below. I will be really happy to read that and like grab the suggestions you will be giving me. And that's it for this video. If you like this video, give a like to this and also comment down below in the comment section that how was this video, what else topic or what else question you are having for me to solve this. And thank you. Bye. See ya.